I am Rudraksh and this is the video demonstration of the task 4.2c. So let's start by understanding the overview. We'll be implementing the repository pattern to decouple data access logic and object relation mapping for better database interaction. Will be used fast member of fast ORM solution for the task. It offers efficient mapping between database entities and application objects. So for the extension method.cs in this file, this it is designed to map data from NGSQL data reader to an object of type T. Let's break it down. First, we see the using directives. These are the instructions that tell the computer which external libraries are on namespace to include in our code. Here we are importing fast member, which is a library that provides fast access to the member of a type, and NPGSQL, which is a .NET data provider for PostgreSQL database. Next, we have a namespace declaration, which is used to organize code into logical groups. In this case, the code is inside the robot controller API.persistence namespace. Then we have a static class declaration named extension methods. This class contains the extension method we'll be exploring. Now let's focus on the map to method. This method is defined as an extension method for the in PGSQL data reader class. It is marked with this keyword before the first parameter, indicating that it extends the functionality of the NPGSQL data reader class. The map to method takes two parameters. The first parameter is of type NPGSQL data reader named dr, which represents the data reader from which we'll be reading, and the second parameter is generic type T named entity, which represents the object to which we'll be mapping the data. Now let's analyze the body of the map to method. The first line inside the method is a null check for the entity parameter. If the entity is null, an argument exception is thrown indicating that the entity parameter must not be null. Next, we create the type accessor for the type of the entity. Using type accessor.create, this type accessor provides fast access to the member properties and fields of a type, which will be useful for mapping data later on. Then we retrieve the properties of the entity object using the getMembers method of the type accessor and select their names. We convert these properties names into a hash set for a faster lookup during mapping. This allows us to quickly check if a property exists on the entity object. Now we enter a loop that iterates through fields of the data reader. For each field, we attempt to find a corresponding property on the entity object using a case-sensitive comparison of property names. If a matching property is found, we check if the value is the data reader for the field is really null. If it, if it is, we set the property on the entity object to null. Otherwise, we retrieve the value from the data reader and set the property on the entity object to the value. And that's it. The map from efficiency and maps data from an PGSQL data reader to an object of the type T. Now for the next file, that is imap.access.cs file. In this file, we see the namespace declaration, which is similar to what we discussed earlier. Next, we have the declaration of IMAP data access interface. Interface define a contract for classes to implement. In this case, any class that implements IMAP data access must provide implementations for the method defined within it. Inside the interface, we have several method signatures. Let's go through each of them. The first method is getAllMaps. It is a method that returns a list of maps. Presumably, it retrieves all available maps from the data resource. Next, we have updateMap. This method takes an updated map object as a parameter and presumably updates the corresponding map data in the data source. Then we have insertMap. This method takes a few map direction as a parameter and inserts it into the data source. It's used for adding new maps to the system. Lastly, we have deleteMap. This method takes an integer ID parameter and presumably deletes the map with the corresponding ID from the data resource. So for the next file, that is irepository.cs. In this file. Similar to previous example, we start using directive, importing npm-SQL. Next, we have the namespace declaration, followed by the declaration of a repository interface. This interface appears to be responsible for defining database operation. Within the interface, we have private constant named connection string. This constant holds the connection string required to connect to the PostgreSQL database. Now let's focus on the execute return method. This method is defined to execute a SQL command and map the result to object of type T. Let's break it down further. The execute return method is generic, indicated by the T syntax before the method names. It takes two parameters SQL command, a string representing the SQL command to execute, and DB params, an array for NPG SQL parameter which is optional and default to null. Inside the method body, we initialize a list to hold the entities retrieved from the database. Then we create a new npm-SQL connection using the connection string constant declared earlier. We open the connection within a using block to ensure it's properly closed after use. Next, we create a new npm-SQL command with the provided SQL command string and associate it with the connection. If there are database parameter provided, DB params is not null, we add those parameters to the command. We then execute the command and obtain a data reader. Within a file loop, we iterate through the rows of the data reader. For each row, we create a new instance of type T and attempt to map the data from the data reader to this object. However, notice that there's a call to a map to method which doesn't exist yet. It seems this method is expected to perform object relational mapping but is not implementing within this code snippet. So the map to method is no for use for the next file we use, that is irobot command data access.cs. Firstly, the declaration of the iRobot command data access interface. The interface outlines the operation that can be performed on the robot command data. Inside the interface, we have our four method signatures. Each method corresponds to different operations that can be performed on robot command data. The first method is getRobot commands. It seems to retrieve a list of robot commands from a data source. Next, we have update_robot command. This method takes an updated robot command object as a parameter, presumably to update an existing robot command in the data source. Then there's insert_robot command. This method takes a new robot command object as a parameter, likely to insert a new robot command into the data source. Lastly, we have delete_robot command. This method takes an integer ID parameter, presumably representing the IDs of the robot command to delete from the data source. And then we have it the iRobot command data access interface outlines a contract for classes that interact with the robot command data in the robot controller API project. Nextly, the file that is map.radio.cs. We begin with using directives, importing the npm-SQL namespace and system namespaces. Next, we have the declaration of map_radio class, which implements the IMAP data access interface. This class serves an implementation of data access. Here, for the map-related operations within the class, we have a private constant named connection string which holds the connection string, as I explained it earlier in the previous course. Now let's focus on the getOnMaps method. This method retrieves all maps from the database and returns them as a list of map objects. Inside the method body, we create a new list to hold the retrieved maps. We then establish a connection to the database using the npm-SQL connection class, passing the connection string constant. We execute a SQL select query to retrieve all rows from the map table. We then update it. Moving on to the update map method, this method updates an existing map in the database with the data from the provided update map object. The insert map Similarly, method inserts a new map into the database using the data from the provided new map object, and in the delete map, deletes a map from the database based on the provided ID. Moving on to map repository.cs file. In this file, we have the declaration of map repository class. This class implements both the I repository and IMAP data access interface, indicating it provides implementation for methods defined in this interface. Within this class, we have a private constant in connections which I explained earlier. We then have a private property underscore dot repo of the type I repository. This property is initialized to this, indicating that map repository itself provides implementation for the repository method. Let's focus on the get all map methods. This method retrieves all maps from the database using the execute reader, and for the update map, insert map, and delete map, I have explained already in the map.it. It has the same properties and the execution. Thank you.
This is video for the task 4.2c, that is object mapping.